Okay, let's look at our RC series circuit. So this is a combination of resistor and capacitor lah. So as you can see here. Okay, so the RMS current passing through these resistor and capacitor will basically be equal sebab they are connected in series. Lepas tu, the RMS voltage across the resistor VR and VC are given by IR and IXC lah. Okay, so V ni walaupun tidak tulis RMS, they basically RMS lah sebab this is an alternating source. Alright. So the phasor diagram for RC series circuit is shown here. As we can see, the current leads the voltage by phi. By phi is the phase angle lah. Okay. So this is in terms of RZ and XC. It's entirely up to you whether you want to use V ataupun XC begitulah, right? So based on the phasor diagram, we can actually calculate the impedance of the RC series circuit, which is the one shown here. So from the phasor diagram, we can see that the current leads the supply voltage by phi radians, and we can calculate that using this equation here, right? So that is basically what you need to know for the RC series circuit lah. Apa yang kamu perlu tahu is kamu perlu be able to apply this equation. Draw the phasor diagram juga lah, okay? Okay. Now let's look at RL series circuit. RL series circuit ni resistor dengan inductor. So they are connected in series. Again, the current across them are gonna be the same. And this is how you calculate the RMS voltage across resistor and inductor. Okay, so the phasor diagram pula dia terbalik macam ni, and we can see that the voltage leads the current by a phi, which is a phase angle lah. Okay. So based on the phasor diagram, we can calculate the impedance of this RL lah. RL. We can calculate the impedance of this RL series circuit lah. Okay, so kita tahu. And then we can then calculate the phase angle, which is phi here lah. Okay, so yang itu kamu just perlu calculate pindah tangent tu di sebelah. Alright, so dia jadi shift tangent. Okay, so that is RC and RL. I hope you don't have any problem in that. But basically what you need to know is just remember that this is how you calculate the impedance untuk each of it lah. Right? Okay, so untuk RCL series circuit pula, these are when resistor, capacitor and inductor connected in series. Again, the current passing through them are gonna be equal. That's why di sini semua I ni sama lah. Alright, so this is how you calculate the RMS voltage across resistor, capacitor and inductor. Okay, so the phasor diagram ni ada perbezaan sebab it depends whether the the inductor punya voltage is greater ataupun less than the capacitor punya voltage. Alright, so if the capacitor punya voltage is greater than the inductor, the angle is gonna be negative. So the circuit is said to be capacitive lah. Okay, so maksudnya semua phase angle untuk bila VC is greater, dia akan jadi negative. Okay, negative lah, angle tu akan jadi negative. So this is how you draw them lah. Kalau kamu tunjuk yang di sini lagi panjang daripada di atas ni. Right? So untuk bila voltage across inductor is greater than the voltage across capacitor, the phase angle is gonna be positive lah. Dia akan jadi di atas. So the circuit is said to be inductive. Okay? So dari sini kita tengok, di sini kamu akan buat lagi panjang lah daripada yang di sini. Alright? Okay, so that is the phasor diagram. And then how do we calculate the impedance is based on this equation here. Again, the impedance is the opposition of an electric circuit lah, okay, to the alternating current. So from the phasor diagram, the current then leads the supply voltage by phi radians. How do we calculate that? We are going to use this equation here. Alright, so if this is actually the same thing as the one written here lah. It's just I've changed it to XL, XC. Macam tu lah, right? Okay. Next, let's look at resonance. Okay, so for the resonance in RCL series circuit, resonance will only occur when the inductive reactance and the capacitive reactance is equal. Okay, tapi ni adalah graph yang I would think that you need to be able to draw it when you are asked to lah. Okay, so apa yang kamu perlu tahu is basically the resistor does not depend on the frequency, and then this is the inductive reactance is proportional to the frequency. whereas the capacitive reactance is inversely proportional to the frequency. Okay. Alright. Lepas tu, what else? So you just have to basically read this through. It's what I've mentioned earlier. And then the value of impedance is minimum. Okay, Z minimum when XL is equal to XC. So the value is going to be equal to the resistance itself. So this phenomenon will only occur at resonance frequency. So how do we calculate the resonance frequency? Is by using this equation here. Okay. Right, so that is on resonance. Now let's look at the example. So we have example 4. So example 4, we have a 2 microfarad capacitor and a 1000 ohm resistor placed in series with an alternating voltage source of 12 volts. So that is the VRMS. Okay, so frequency there 50 Hertz. Calculate the current flowing. So how do we do that? We are going to use VRMS equal to IRMS Z. Okay, so sekarang ni kita mesti tengok Z. Kita akan guna Z sebab sekarang ni dia bukan pure resistor, pure capacitor ataupun pure inductor. So Z is bila dia ada combination. Okay, so sekarang ni Z ni adalah R square plus, so this is an RC circuit, so it is XC lah. Okay, so yang macam ni. So from here, we are gonna calculate the value of Z lah. Okay, so Z, I'm not gonna substitute everything. So you just have to do it on your own. But the value of Z is equal to 1879.6 ohm lah. Okay, and the value of XC tu kamu akan dapat 1591.55 ohm. Okay, so ini adalah value yang kamu perlu dapat. So the current, RMS current is gonna be equal to VRMS divided by Z, where this is 12, this is 1879.6, which will then give you 6.38 milliampere. Okay, next the voltage across the capacitor, so that is VC. How do we calculate that? This is IXC. Okay, so VC is equal to 6.38 milli, XC is 1591.55. So kamu darab ni, kamu akan dapat the voltage across the capacitor to be equal to 10.2 volt. Right? Lastly, the phase angle of the circuit, that is just tangent phi XC over R. So this is shift tangent 1591.55 divided by R, which is 1000. So kamu akan dapat the phase angle to be equal to 57.9 degree. Okay, so that is example 4. Let's look at example 5 here. So example 5, this is an RCL circuit lah, sebab dia bagi kita this is VR, this is VC, this is VL. Okay, so with the aid of a phasor diagram, determine the applied voltage and the phase angle of the circuit. So sekarang ni untuk kita draw this, we have to see whether the inductor is greater than the capacitor ataupun tidak. So if we look at the question, we know that the voltage across the inductor is greater than the voltage across the capacitor, meaning that our drawing will be more upwards lah. Okay, so dia lagi banyak di atas. So this is VL, this is R, I, and then this is our V, this is V. So that is our phasor diagram. Dan sudah, itu je yang kamu perlu lukis. Okay, this is actually VR. Okay, so lepas tu dia minta apa? Kita perlu cari applied voltage. So that is the supply voltage V. So how do we calculate that? VR square plus VL minus VC square them, then square root this. So if you substitute all of it, you will get 251 volt as the answer. Okay, so the phase angle is just tangent phi equal to VL minus VC over VR. Okay, so instead of guna X, kamu boleh guna dia punya voltage juga lah. Okay, so untuk yang ini kamu akan dapat 52.4 degree. Right? Next, calculate the current flows in the circuit if the resistance in the resistor is 26 ohm. Okay, sekarang ni 26 ohm, maksudnya kita perlu cari apa? Kita perlu cari I lah. So, VR is gonna be equal to IR. Okay, so sekarang ni I is basically just equal to VR divided by the R. So the voltage is 153 divided by the resistance, which is 26. So it gives you 5.88 ampere. Okay. Question C pula, we have to calculate the inductance. If the frequency, this is 50 hertz. Okay, so this is 50 hertz. So now we have to calculate the inductance and capacitance. We know that that is XL 2 pi FL. So we are looking for L. So how do we find XL sekarang ni, which is the inductive reactance? We can use the formula from the RMS. Okay, so VL I XL. So dari sini kita boleh buat macam ni. Okay, so yang ni kamu akan dapat 53.4 ohm, and then the value of L ni, rearrange untuk L, this is basically XL divided by 2 pi F, so you will get 0.17 Henry. Okay, so that is the inductance lah bila frequency tu sudah berubah. Next one, we have to find for the capacitor. So this is 2 pi FC. So we are looking for XC. So how do we find XC? We are going to use the voltage across the capacitor lah, IXC. So XC is VC divided by I, which will give you 19.56 ohm. Okay, so dari sini kamu akan substitute, rearrange dulu 2 pi F XC, which will then give you the capacitance to be equal to 1.63 microfarad. Okay, all right. Oh, not micro, sorry. It's times 10 negative 4. Itu biasa pula. All right. Okay, that is question C. Lastly, we have to calculate the resonant frequency. Remember, resonant frequency is FR equal to, I think it's given in your formula sheet, so it's not really a problem lah. So this is 2 pi LC1. Okay, so this resonant frequency, kamu substitute lah. L yang kamu dapat tu mana satu, yang ni, lepas tu C tu substitute sini, square root dia, lepas tu kamu kira, kamu akan dapat the resonant frequency to be equal to 30.2 Hertz. Right? Okay, so that is the solution for example number 5. And that is all for our third subtopic.